we're going to talk today about making a site model. So this is my model. I've punched out a little hole here. It's a little topography. This hole is where my building is going to go. This is where my site is. It's just this little grade, and it looks like a little pizza pie slice. So I'm going to make sure first, the biggest thing is that my units down here are in inches because we were making this for the CNC. I'm also going to use my distance command to measure some of these components here and make sure that I'm not over 4 inches in height if I'm cutting out of foam, and that I am not bigger than the piece of foam that I have. The foam that I have that I'm going to cut this out of is 4 foot by 4 foot, so that is 48 by 48. Another way of checking this would be to go into our top viewport, make a rectangle, and make that 48 inches by 48 inches and see if we can't align these things concentrically. And there we go, it fits perfectly. So I'm going to start off there. I like to draw my actual stock box from the top viewport so I can know exactly where I'm positioning my material inside of that box. The next thing that I'm going to do is open up RhinoCam. This is on the PCs in the lab. So I'm going to come up here to the top bar where it says RhinoCam 2020. Hopefully by the time you're seeing this, it's 2023 or later. And I'm going to open up Mill. It'll pop up with this bar right here to the left-hand side. And I'm going to come up here to the tool browser and load the tool browser from the desktop. And it should say that my tools have loaded successfully. Now I'm going to close this one out because I don't really like looking at the tools. And I'm going to look at my model from all the different viewports. And so the one thing that I don't like right now is that my model is sitting kind of like weirdly above my middle point. And so I need to align some things and tell RhinoCam what my stock box is. So I'm going to work through this icon in preparation for getting this ready to be milled. So stock, box stock. And then if I drew that rectangle out, it's going to know that by default it is 48 inches by 48 inches, and it's going to encompass the entire height of my model. My piece of sheet stock, though, is 4 inches high, so I need to include that it is 4 inches high. This is the value you will be changing. It is imperative that you get that value correct. The next thing that I'm going to do is align the stock box. So if I hadn't drawn that rectangle out, I would actually be aligning my art or my topo or my model, whatever you want to call it, inside of the stock box that I just defined. Now I can click northeast, southwest, south, southeast, northwest, anything, and it's going to align in the same area in live view here. But the important one is the Z alignment here. So if I look in it from the front view, I've got it aligned to the top. You can align this to the bottom. You can align this to the center. This is one of those things where you get to decide what you want now. I have modeled this perfectly to exactly the height that I want for my model stand. This is going to be the thing. So I'm going to align it to the bottom, and I'm going to hit OK. The next thing that I need to do is align the world coordinate system. So I've done the stock. The next one is world coordinate system. This is uber important. You will ruin your stock material or potentially the machine if you refuse to do this portion. So right now our Z point is set, about 1.25 inches above the base of the model, and that's not right. So we need to align our world coordinate system to the stock box at the lowest Z in the southwest corner. So from the perspective view, you can see that it is moving it from this point here down to the bottom. That is, again, the stock box, lowest Z, southwest corner. Perfect. Cool. So we're most of the way there. Now I can take a little look at my model here. I'm going to get rid of this rectangle. No, I'll leave it in there for now. But pretty much I want to be able to select this face, the face where my building is going to sit. And I can do that a number of ways, but my preferred way is to duplicate the face border so I can create one continuous curve around the entire outside. So I have Control-Shift selected the top here, and I'm going to do dupe face border. It's created 2 borders for me. It's created this inside square, and it's created the outside profile. So then when I do something like cell curve, I get these 3 curves that I've drawn. So the first thing that I'm going to do is I need to remove a bunch of this foam. And I'm going to go into 3-axis horizontal roughing. The roughing pass is what removes a majority of the bulk material from our model. The first thing that I have to do is I need to tell the machine where to work. If I don't do this, it's going to assume that it's cutting around all of this foam. And I'll let you see what that looks like. The way that we rough out with foam is from this long foam flat mill, or excuse me, it's foam long flat mill here. And then the feeds and speeds, I hit load from tool. They should auto-generate. This tool moves quicker than most other tools because we're cutting foam, which is a low density material. The clearance plane is the height above the stock box that the tool moves when it's not cutting. And so this is where it's like super essential that you put in that your stock material is the actual thickness of your stock material. So it is going to 4 inches, and then it is adding a 1/4 inch above the 4 inches. So it goes up to 4 1/4 inches, and then it moves across the material. I'm not going to do anything in advanced cutting parameters right now. Cut levels. So the general rule is that you want to move no more than 50% the tool diameter over or down in any direction. If I'm cutting this out of foam, I can cut a little bit more. So if you're cutting out of MDF, it needs to be 50% here for your step down. For foam, I'm going to cut a little bit more, and I'm going to do something like 80% down per pass. And then on cut parameters, this is the amount that the tool steps over per pass. This, for a roughing pass on any material, should always be 45%. And then I'll hit generate. And it's going to take a long time to generate this because I didn't establish any control geometries. And what it will do is it'll create this giant job that if I were to simulate it to the end, it's going to rough out all of the material. If I can hide these tool paths, it's going to rough out all of the material. So all of this foam that is sitting between the bounding box edge and my model, it's going to rough it away. And that is a huge waste of foam. That is a huge waste of time. So we need to come in here and be sure to establish our control geometry. We're going to select curve and edge region, and I'm going to select these curves around here. But I should be able to select the curve that I drew around the face border. What you saw previously was what would happen if I didn't select and duplicate the face border, is I would have to select each of these individual line segments between all of these points. And I'm going to hit enter, and I'll hit generate again. And now we should just see blue lines over that little pizza pie slice. There we go, that's perfect. And so now if we simulate this again, there we go. It's just removing layer by layer the bulk of the foam. And what we end up with after that is this sort of rough idea of what our geometry is. And so the next thing that I want to do is I want to create a finishing pass. So this is the rough one. I want a smoother version of this. And to do that, I'm going to go to machining operations after I've simulated this. I'm going to go to 3-axis and 3-axis parallel finishing. And parallel finishing will work its way back and forth across the model, giving you this topo surface. And so since I already have the outline selected, drive region 1 is selected here. It is highlighted green when I select it in the hierarchy here to the left. When it is deselected, it is yellow. So it's a good way to go through and see what's been selected. And if I were to generate this now, it's going to try to parallel finish down in this box right here where my model sits. And that's not really a good idea, and it's not a good use of time. This right here is a flat surface area. We want to use parallel finishing across things that are non-planar surfaces. So like this geometry here is something that is an ideal candidate for parallel finishing. So what I can do is I'm going to tell RhinoCam by selecting this outside profile that I want you to work inside of here, but then I'm also going to select this curve here. And it's telling it that I want to work inside this green line, but outside this yellow line. And I'll hit enter. And then I'm going to select a foam long nose bit. I'm going to load my feeds and speeds from the tool, keep my clearance plane the same, and under Z containment, it is really, really important that I specify that the lowest Z is the actual 0 point on my model. That way this bit doesn't cut into the table. And then for the last thing is the tool percentage step over down here. You should read through all of these things and see what they do in time, but the one that's important to you right now is your percentage tool step over. And that's saying that using this tool, which is 3/8 inch thick, that you're stepping over 25% of 3/8 per pass. And I'm going to generate that real quick so you can see what that looks like. And turn those tool paths back on. Uh-oh. And so these blue lines you can see are 25% of 3/8 apart from one another. I don't know what that number is, but I know that if I come in here and I simulate this, I'm going to see this tool cut back and forth and back and forth and back and forth. And this is what you're going to be seeing in real time on the machine. Not sure what these lines are here. They look like they might be a rendering error. But the important thing is that if I turn off these tool paths, that you see these sort of gouges in the material. And so if you're cutting out of something like pink foam, something that's a really sort of, for lack of better words, terrible material to be milling, this to me is an acceptable finish. Because in order to get this crit level finish, I'm going to need to go through and I'm going to need to sand, I'm going to paint, I'm going to sand, I'm going to paint, and I'm going to do a bunch of different coats over this. So if I've got something like foam, 25% step over is fine. For instance, though, let's say that I'm milling out of something nicer, like a tooling foam or a hardwood. I'm going to come in here and I'm going to set this to maybe 15%. And then I'm going to generate that. And if I play that to the end, under simulate, it's going to take a minute. Let it think. We zoom in, you see these lines get closer together, and this becomes less noticeable. Granted, we're like zooming in, so if this is 15% of 3/8, I guess, you know, like 4 or 5 of them should be an eighth of an, or 3/8 of an inch. So we're never going to see it this close, but this is an almost negligible level of step over here. Everything looks very flat and even. You'll need a light sanding. I would probably never go less than 15% on a step over, because this is going to take a really long time. I'm not going to get into like the nuances of what makes it take a really long time, but it's just important to understand that the finishing bit will always move slower than your roughing bit based on the geometry it is interacting with. So if I click on this, I can just, these little flowers that popped up, I think I accidentally dragged my model. Yeah, there we go. So these flowers that pop up over here mean that it needs to be regenerated. And so we'll regenerate that. And then the last thing on the model to actually set up for is going to be this pocket here for the building. And I'm using that word pocket deliberately because pocketing is a Rhino cam function. So now at this point, if I simulate this whole job to the end, you're going to see that we're pretty close to the surface. And the biggest thing is that I don't have a bunch of material over this area. It's been carved down significantly, but it's not the actual size of where the building or structure is going to sit. And so what I need to do now is finish that area out. And so I'm going to come up here to Program, Machine Operations, 2-axis, and do what is called a pocketing command. And so I currently have the outside selected, so if I were to pocket right now, it would give me something awful. So I'm going to remove all, and then I'm going to select a flat area region. And what that does is that allows me to just click on this little base here and then hit enter, and I've selected that outside geometry. I don't have to duplicate face border. If I'm working with something that has a bunch of streets or other planar elements, I can just click all of the flat area regions and knock that out that way. I'm going to keep my long foam flat mill as my tool for this. And I click through these tabs just to remind myself of what I'm looking at. And then on cut levels, I'm not going to do anything here. And this is the only time I won't adjust the cut levels, because this is going to cut directly down onto the surface of the flat area region. On cut parameters, though, there's a few things you need to change. The first thing, if you look at this infographic right here, is the stock value. This orange line is the actual model surface, and this light blue line is the cutting line. And so by default, a lot of these tooling operations are going to want to leave a little bit of stock there for you to remove with a finishing pass, or for you to remove with some other pass. But on this one, I want to select 0, so it cuts all the way against this wall right here of my model surface. And the final thing to change is the percentage tool step over. Again, I'm going to use 45%. And it's important right here that we're using a flat end mill because we're cutting a flat surface. The way you got those sort of lines across your model from a finishing pass won't happen on flat area regions if you're using a flat bit. So we'll hit generate, and what it should do is create a bunch of little light blue lines right in there. Sweet, that is perfect. And so I'm going to do simulate this one, and I want you guys to pay attention to something. It carved it out, but here's the thing. We're using a round bit. If you look at this right here, this is our bit that we're using, generated by RhinoCam, and that's by scale, a good representation of our bit, but it's a cylinder. And so you're never going to get 45-degree angles on the inside of a pocket that is carved out with a cylinder. There's a couple of ways that you could fix this. If you were to use something like a chisel on the inside, maybe you can sand things down, or you're using a 1/2-inch bit, so you know, based on the geometry of that bit touching the surface, what this radius is. You could even 3D model a radius of the plug of your model that fits in there. So you can work with this to your advantage to create a tighter fitting component into your site model. But I know that if you're 3D printing something, you're going to want to know the exact geometry and dimensions so that it nests perfectly in your site model. So you should just be aware that no matter what bit you use, you're never going to end up with a hard 45 or 90-degree angle in here to nest these shapes into. It'll be pretty close. You'll have with a 1/2-inch bit, you'll have a 1/4-inch radius. So it's not huge, it's not glaring. If it's something like foam, you could probably just get in there with a X-Acto or something and cut it out so it works. But that is just so you know what you're going to end up with. So again, the whole thing has been pretty much done. If I wanted to click on setup 1 and simulate it again, just so we can see all the way to the end what we're going to get. It's going to take a minute. We've got the whole model cut into this big block of foam. The only thing that is happening now that I don't like is that it's inside of a big block of foam. And so I'm going to need to cut this whole shape out. So we're going to go back into program, and I'm going to control Shift select the bottom now and do duplicate face border, or dupe face border, and that'll give me this curve on the outside. And I'm going to run a 2-axis profiling job using the curve region that I just drew. I'm going to hit enter, and I'm going to use the long flat nose bit. And so what that means is that this tool that is flat along the bottom is going to allow me to cut this all the way out. I'm going to load those feeds and speeds from the tool again. And under cutting parameter, I'm just assuming you're using something like a foam again. I'm going to do what is called a conventional cut direction, meaning that as the work is being cut out, it is just going to follow in one direction. And then it's going to ask me if I want to use the inside or outside of a closed curve. I'm going to use the outside so I don't cut into my model. And then I click through all these things. I need to add bridges and tabs to this because I don't want this model shooting off into space when it's done being cut out. It's pretty big, so I'm going to add something like 8 tabs to this. And then on entry and exit, for every profile shape that I cut, I'm always selecting none. And then on cut levels, it's going to ask me some things. The first question is, where's the location of my cut geometry? We could do it like Dora the Explorer, and you could scream it at your screen right now, but it's at the bottom. And so notice this yellow line is at the very bottom, and then the total cut depth is going to be, it's 4 inches. So our model foam is 4 inches. Our model is only about 3 inches in height, but our model material is 4 inches in foam. And then this one right here is your rough depth per cut. So in each one of these passes, it's going to take a certain amount of material out. And so you don't want to cut all 4 inches at once. That would be pretty catastrophic to your model. So we're going to cut 0.8 inches at a time because we're using a 1/2 inch bit, so we should really be cutting, actually, let's make it a 1/2 inch. So we'll do 0.5 inches per pass. And so 0.5, I've got 4 inches, that should be 8 passes around the model. We'll hit generate, and I should see, yep, if I look at the side, 1, 2, 3, 4, 5, 6, 7, 8 lines, and this bottom line has this little notch where it's going to cut out a little tab for me. And so I'm going to simulate this to the end. Perfect. And from the top, you can see I have cut out my material, and I have all of these little tabs around the outside. And so this is ready to go to the machine. I will highlight setup 1, and I will select post, and I will save it to a file that is on the desktop called jobs. This is pretty good and ready to go. This is by no means an all-encompassing video. This will not sort out all of your problems, but it will get you started with something to do. So please reach out to a lab monitor or myself if you have any questions. But this should get you on the right track.